So here's number 4 from the puzzle piece practice test. Sam claims the solution to this is 92. She wants to prove this claim using the 4 assumptions below. So like terms can be added or subtracted, distributive property, addition property of equality, division property of equality. Sam chose the following steps to prove her claim that the solution to the equation is 92. So here's her steps. You're going to match the number of the assumption used for each step in the proof. So if this is my given, so here's my original problem. What did she have to do to go from step 1 or from the given to step 1? She distributed. That's what I say to do. Like every time you see it in a problem, do that first. There could be other ways to solve still that you might see on your test, but like that to me is always step 1. So that distributive property was assumption 2, right? So I'm gonna make sure that I put assumption 2 with step 1. Sorry, the internet is horrible in this location. Okay, I think it's working again. Let's see. Okay, while it catches up, hang on. All right, but the distributive property, which was called assumption 2, I don't know what they have for your labeling, but we'll move the labeling in a second. All right, now to go from step 1 to step 2, what did they do? They combine like terms because we went from 12x plus 4x to now 16x. And that combined like terms was what assumption?
1.
Okay, good. Then going from step 2 to step 3, what did they do? They added 20 on each side. That would be anytime you do something on each side of the equal sign, that's a property of equality. The specific one would be what you did on each side. So you would have had to plus 20 on each side. And that's my addition property of equality. I'll just abbreviate. And that would be assumption 3. There we go. Lastly, process of elimination, but also you would have had to do this anyway. How would I cancel out that 16 next to the x? You would have had to divide on each side, which then would be your division property of equality. And that's my assumption 4. So then for the drag and drop, it goes assumption 2, 1, 3, 4. I'm going to make sure the key is correct right now too, just in case, maybe. Because we teachers make these study guides. Occasionally there's mistakes, but we try to make there not be mistakes. So 2, 1, 3, 4. And that is correct. So you might see like a good question on your test would be asking you, are these the correct properties that go with these steps? Is there a mistake in the labeling of the properties? Is there a mistake in any of the steps? Questions on this one? Okay, questions on others. Let me make sure that this one gives you partial credit. Okay, yeah, I'll make it to where it gives partial credit. It'll probably take a few hours for it to give you the partial credit for your past submissions. But usually when I grade your test, I give partial credit anyway. So that'll fix that. Haley? 15. Okay, compare the rate of change and initial values. I didn't use the phrase rate of change that often during class. I think I did during Stride when it came up. What's another word for rate of change? Slope. All right, so rate of change is also known as your slope. It's what it's changing by each time. So you're looking at it from a few different displays. And there's a few like different definitions for slope, like a few different methods you could use that sometimes work better for certain displays. I think the one that might work for all of these is either rise over run if it's a graph. But if it's from a table, then I suggest you use the y2 minus y1 over x2 minus x1. Which is literally the same. It's the same thing. It's just one's easier for a graph, the other one's easier for a table. So like example here, pick two coordinates. It shouldn't matter which ones you pick. I'll pick like this pair and this pair because they're smaller numbers. And I pick one of them to be my x1, y1, and the other one to be my x2, y2. Like, see how the x's are here? I shouldn't label the x's ever as like a y1, y2. All right, but each coordinate pair you're labeling, and then you're plugging into that formula. So the way that I labeled it here, it would be 4 minus 0 on top, because y2 minus y1, and then 9 minus 2 on the bottom. With x2 minus x1. What's 4 minus 0? 4. What's 9 minus 2? 7. So my rate of change for function 1 is 4/7. Now for function 2, since that's a graph, it's probably easier to do rise over run. So let's do that. It has 2 points already marked. Consider using those 2 points. Those are clear and easy to see. And you're counting the rise to go from the left point to the right point. I'm going up, so my rise should be positive. What's my rise for this? 1, 2, 3, 4. I agree. What's my run? And your run should always be positive. So 1, 2, 3, 4, 5, 6, 7. I also agree. So it has the same rate of change as function 1. So you would put 4/7, and you would put that there equal. Did anyone get that one totally right? Can you confirm that that's the answer? Okay, let's see. 4/7, 4/7, and they're equal. Let's see if that marks it right. It's not 1/2 though. I disagree. Let me check again. Yeah, I don't agree with that. I'm changing the answer. Because it should be 4/7, not 1/2. I'll check again one more time, but that's not right. I'll even check from like another coordinate just to be sure. So say I do 8 minus 4 over 16 minus 9. I get 4/7. Yeah, it's 4/7. Yes? Sure. Function 2. Let me look at it again. These points I could see really clearly. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. Yeah, it's 4/7, not 1/2. Questions on this one? All right, questions on others? Gail? Number 2 on this study guide. Okay, so on a trip to visit her mother, table 1, stop talking. Anita has already driven 180 miles. She's currently driving at an average speed of 60 miles per hour. Graph the function that shows the number of hours H the rest of the trip will take and the total number of miles M that Anita will drive. So it would probably be easy to have the equation first, even though it's not asking you for the equation. That would help me graph it. So what have we been focusing on this unit? Like what type of line? What do we call them? What's this unit called? What formula have we been using a lot in this unit? I can't hear. Can we say things like not whisper them? When you go to a job interview, are you gonna whisper your answers to whoever's interviewing you? Okay, so can you please just tell me like what the formula is that you've been using a lot? Slope intercept is what it's called. Thank you. Slope intercept form. What's the formula for slope intercept form? That makes it really easy to graph when it's in that form. Slope is also called what? Rate of change. So whatever it's changing by in this situation is going to be my slope. So what is it changing by? It's changing by 60 miles each hour. So if I'm writing this in slope intercept form, it's going to be something like this. 60x, because for every 1 hour, 60 miles. And then y-intercept is usually like your starting point, right? It's what you would graph first when you're graphing. So is there a starting amount in this situation? Or are they starting at 0? They've already driven 180 miles. So they're starting at 180. We want to graph to show the number of hours the rest of the trip will take and the total number of miles, so including the 180 that Anita will drive. So this is easier to graph. So that means I need to have my starting hour that they're now tracking this at 180. So I'm going to drag this up to 180. If you're not sure where the 180 is, just kind of like see it goes up by 1, 2, 3, 4, 5, right? So it's splitting it into fifths. 80 would be 4/5. So like right there. Does that make sense? Okay, we'll try it again. 20, 40, 60, 80. So that's 180. And then it goes up by how much each hour? So what's 180 plus 60? Good. So then this one should be at the 240. So at the 200 plus 20, 40. At 2 hours, so another 60. How many miles would that be? 300, I agree. Another 60 would be what amount? So then 20, 40, 60. Another 60 would be what amount? So then 24, no, just 20. Good. And then another 60 would be what? We're at 420 here. So then 20, 40, 60, 80. Another 60 plus the 480. So then 20, 40. And one more time, another 60 would be what? So then all the way up here. Oops, right there. And then you should have a straight line. This unit, all we've been looking at are straight lines. My slope is 60. My y-intercept is 180. Let me make sure that marks it all right. And it did. Questions on this one? Did anyone have a question on the constructed response, or was that just like so easy?
I was just so.
Because I didn't like, I'll post a key later in Schoology. Make sure you check your answers. I didn't grade it for accuracy, that one. I graded it for completion. You'll have to check later that it's actually accurate. Any questions on any of the study guides? Might have time for one or two more. Tomorrow you take the real thing. 16? Okay, shh. Table 6. So the equation below is the standard form of a linear equation. AX plus BY equals C. Which of the following is an equivalent equation? Look at all your answer options. What's alone? The Y. So basically, I need to take my standard form and rearrange it so that the Y is alone. And then by doing that, do you guys know what type of equation this makes? Slope-intercept form when you isolate the Y. So even if A, B, and C were numbers, you could rearrange it by isolating the Y, and now you have it in slope-intercept form. So anyway, whenever you're isolating something, start with what's farther from it. So would that be the B or the AX? And how do I cancel the AX? Whatever you do on one side of the equal sign. Now this might be harder for you because these are all letters, but it's still the same steps, even if they weren't. Are C and AX like terms? So you leave them alone. You don't combine them. But look over here. It looks like they're putting the X term first. So I'm just gonna switch the order. It's gonna be negative AX first, plus C. I didn't change anything about it. They're still the same signs. This one's still negative, this one's still positive. I just changed the order. Now Y is still not alone. What's opposite of multiplying by B? And whatever you do on one side of the equal sign. And do it from each term. Remember, that's what you would do if it was numbers. And then, can I simplify anything? No, because I don't have any like terms. What answer does this best match? I agree. And it could be shuffled on your screen, but it has to be the one where the AX over B is negative. And then it has to be C over B, and that has to be positive. So yeah, that's correct. Questions on this one? All right, last call. This might be our last one for the day. I do have, wait, no, today's Tuesday. I like. Just ignore what I said. Barnaby? Number 9. So if the bell rings, you're free to go. Do not line up. But if you want to stick around and see number 9, you still aren't allowed to talk over me though. So don't be it was the one with a negative AX. It's right here. Positive C over B. Edwin, I can write you a pass and I can check those notes you had out. Okay, but no talking over me, no lining up. So the school sells pens for 75 cents each, pencils for 25 cents each. Anthony spent $6.25 to buy a total of 11 pens and pencils. How many pens did he buy? So this is similar to your constructed response test. You would have to make a system because you have 2 totals here. What's one of my totals? That's what something costs. 625 is the total he has to spend, and then what's the other total? So use that and then now make your equation. What should go on the other side of the 6.25? Okay, good. I'm gonna assign random variables for each. So X will be for pens, Y will be for pencils. And then for the other one, it should be, and then from here, use whatever method you want. What method do you think is easiest on a test? I would do typing into Desmos, but it's really up to you. Where they intersect, that XY is the solution to the system, but it's only asking about the pens. So really, I would only put whatever the X value is for that. Does that make sense?